My presentation is on different types of rocket fuels I made and which ones will work the best. Recently, I have made some model rockets. They come with model rocket engines, which mostly contain black powder. But I wanted to do some of my own research on fuels and try to make my own, and then compare their performances. My hypothesis when I started this experiment was the more reactive the fuel, the farther the rocket will go. This video is a video I made of a model rocket that I put together myself. For my background, rockets were first invented in 10th century China to launch arrows. While the first liquid rocket wasn't launched until 1926 by Robert Goddard. For my procedure, I am going to mix the potassium nitrate and sugar in a 60-40 ratio. Then put the mixture in a low to medium heated pan until the sugar melts with the potassium nitrate. Then I will pour the now liquid mixture into a container. Then it's ready to go once it dries and becomes a solid. For the acetone, I'm going to pour it into a container and mix it around the container until the liquid turns into a gas. Then I will repeat the same steps for the acetone rocket, but it will be for the isopropyl alcohol rocket. As shown on the graph, I did 3 launches for each type of rocket. The red is potassium nitrate, the blue is acetone, and the black is isopropyl alcohol. You can probably tell which one went the farthest. Rocket 1 for potassium nitrate went about 100 feet, for acetone it went about 36, and for isopropyl alcohol 15. Rocket 2, potassium nitrate went 75, acetone went 40, and isopropyl alcohol went 18. Rocket 3, potassium went 85, acetone went 32, and isopropyl alcohol went 20. Overall, potassium nitrate went the farthest and performed the best. Acetone and isopropyl alcohol performed barely as good as potassium nitrate, which surprised me because I thought they would do better. The solid fuel did the best as shown on the graph, while the 2 liquid fuels seemed to not perform as well, which was weird because I thought they were going to go farther. The liquid fuels seemed to also be less predictable and less controlled, meaning they didn't always go straight and would most of the time catch fire because there was still some liquid left inside of them. Overall, I learned a lot about these fuels, and I don't think my hypothesis was supported because it seemed that it depended on the length and force of the reaction instead of the speed the reaction happened. Because if it depended on the speed the reaction happened, I think the 2 liquid fuels rockets would have gone farther than the potassium nitrate because they went off pretty fast. I have seen people use a pressurized tank to control the release of the liquid fuel, but I did not have a pressurized tank, so if the liquid fuel could be released in a pressurized way, I think that they would have performed better than in my experiment where I just put them in the container and then lit them. These are all of my sources I used before and while I was performing my experiment, and they helped me understand more about rocket fuels.